let us briefly now review the different kind of approaches to have failure tolerance and proof of work, what I have been explaining before, simply because it is the most widespread version of this to have failure tolerance inside of blockchain-based systems. Now we're going to see a few others. Very briefly, there is something that you have to Sorry? We are still in the page 17 of the session 2.2, but it's going to take us 5 minutes, 7 minutes. Okay. Failure tolerance approaches. Then, there is something that is fundamentally important for you to remember with respect to the scalability issues that blockchains have with respect to the information that they can store. One is, remember, blocks contain verified transactions. There is a physical limit to the amount of transactions that a block may contain, that is the block size that you have inside of the system. There is another limit that you have in the amount of transactions that you can process per unit of time, that is the time between blocks that get added into the blockchain. Remember, in Bitcoin you have new blocks getting added every 10 minutes. If you would like to scale then a blockchain-based system, you have two options. Either you increase the block size, so you increase the number of transactions that you can add per block, or you decrease the time between blocks, because in both ways you can process more transactions per unit of time. There is a problem, however, which is that information travels through a network, and then if you have larger blocks, it will take longer for the blocks to propagate in the network. There is another aspect here. As I said, the larger the blocks, the more information you have to transmit to the network. Therefore, it takes longer for the blocks to propagate inside of the verification layer. And you have a trade-off that all the blockchain-based systems must deal with. If you have a smaller interblock time, you have more transaction capability. You are able to process more transactions per unit of time. However, if you have more time between blocks, you have better consensus because the blocks are able to travel through the system. So what is best? It's a thing that is intermediate between the two things. The important scale that you must remember inside of blockchain-based systems is that there has to be a trade-off. Sorry, the important thing is how much the diffusion time relates to the time between blocks. What is particularly important is that if you look at this ratio, again, diffusion time divided time between blocks, if the diffusion time is small compared with the time between blocks, what you have is that you do not have you have a good consensus, so you have a blockchain, but as the time between blocks, think that, for example, Bitcoin, a new block is added every 10 minutes. In Ethereum, a new block is added every 12 seconds. The more you go into the direction that the time between blocks is smaller and smaller and smaller, the more you have what is called forks inside of the system. A fork is a point in which two different nodes that have been participating of the proof of work find the new block. Remember, they only have local information that is at the same height, that follows from the same block. When this thing happens, one of the two blocks becomes unnecessary inside of the system, and actually is not valid anymore at the point in time. This is true for every kind of blockchain-based system. There are different kinds of families of verification processes you can have. We have been talking about proof of work. there is in which the probability of finding a new block is proportional to the computational power that you devote to the process of mining. In proof of stake, there is something different, which is the probability that a node is selected as the generator of a new block, that a node is selected as the generator of a new block is proportional to the total amount of tokens that this user has. So the more wealth a user has, the more likely is going to be this user the one that creates the next block. An alternative to proof of stake is not saying that it is just important how many tokens this user has, but the how long this user has been holding these tokens.
By user you mean the node, the miner.
By user I mean anybody that can show that he owns tokens, and this can be a user, yes, but it can be.
But in the two parallel paths, it's not the top. It's not the one.
Yes, it is. It is exactly this. In this, no, you're right. It is exactly at the level of the transactions. It is. I received all these tokens. Based on all the tokens that I have more probability of finding the next block. It's exactly at that level.